So welcome to this starting chapter of mechanical properties of fluids. Now the basic difference between fluids and all the rest of the solids, if this is solid, this is fluid, is that solids has a definite shape, whereas liquids does not have a definite shape. Okay, so this is what we know of liquids and solids. The main thing in this chapter that you have to concentrate is not on the properties of the fluids but on the mechanical properties. So the first thing that you have to know is what is pressure. What is pressure and how fluids exert pressure. The formula for pressure was F into A, that is force divided by area. Now, if I apply a pressure in this container, if I apply a uniform force, that is a force F, and this force is distributed uniformly over a surface area of A. Similarly, for this small container, if I apply the same force for the area A2. Now the pressure in this particular container, in this particular system will be more because the area is less. The perfect example is when you use a needle, that is, when you use a needle and you press onto some object or cloth, you see that it easily pierces the material. It comes out. But if you apply the same force with a blunt object, say suppose with a blunt object, you're applying the same force. Same force F is being applied, but you are not being able to pierce the cloth. You are not being able to make any impact. So why is this so? As you know, pressure is equal to force divided by area. So when you decrease the area, if you look at this particular formula, when you keep on decreasing the area, when A decreases, the pressure increases, that is force remains constant. When you keep on decreasing A, the pressure that is applied in the objects increase. So the minimum A will give you the maximum pressure. So this is one of the properties of liquid, that is, you have to know what is pressure. Now, liquid always has pressure. So now we have defined pressure. Now let's see the pressure of liquid. As you can see, this is a container. So liquid is above this, another layer of liquid is above here, another layer is above here, another layer is above here. So now what I can say is liquid can be compared as to tin sheets. Say suppose this is your tin sheets, and this tin sheets are placed one above the other, and each tin sheets has a density and has mass. So if there is mass, there will be density. So if this has density, the tin sheets will have weight. Weight means force. Weight means what? mg. That is force. So now we can see, if we compare the example of tin sheets, what I can easily observe is that the lowermost tin sheet will experience greater force. The reason being this, two more tin sheets are above him. Whereas if you look at the upper tin sheet, he is experiencing no force, but he is applying a force downward, but upward he is experiencing no force because there is no one above him to apply force. If you look downward in the middle sheet, you can see that the force experienced by this, name this as A, name this as B, and name this as C. So the force experienced by sheet A is none, is 0, because there is no sheet above it. The force experienced by B is due to sheet A, due to sheet A, F of B due to A. But force experienced for C is experienced by C is for A and for B. So this particular concept can be applied in understanding the pressure of the liquid. The above layer has some density say rho, density of liquid say rho, and therefore it will have weight. And this weight will vary. This weight will vary as if you go down, the weight of the mass that is above it will increase. So h. So weight will vary on h. Now what I can see is that the pressure in the above surface is less and the pressure below is more. The reason behind, the force that has been applied due to the weight of all the liquid that is above it is applying a pressure in this particular area. So this is the pressure. So in this way, by understanding this concept, we can proceed further into understanding the mechanical properties of fluids.